Hi everyone, this is Amira from Team 14. Today we'll be giving a quick presentation on our progress and also a quick demo of our IoT plant watering system. So I'll kick it off with the progress and timeline that we've made so far. Based on what we planned, we're still on track to complete implementation and testing of the preliminary system. We've conducted research on multiple hardwares and tools, and together we decided on a design that makes the most sense for what we plan to implement. Currently, we've purchased all the hardware and assembled the initial system. Next step in terms of development is to implement the text messaging so users can be notified of the pump activation. Lastly, for testing, we have tested that we're able to get readings and activate the pump as expected. But moving forward, we will continue testing our system as we add in the text messaging notifications and refine our system a bit further. Now I'm going to hand it over to Craig to go into a bit more further detail on the progress of our prototype.
Thanks a lot, Amira. Craig Williams, Team 14, and I'll be walking you through the progress slide. First, let me set up a little bit of the background. Putting this together, we worked with the Adafruit Clue board, and we also leveraged CircuitPython for development purposes, which was super helpful. As we updated the code in real time, it would recycle the device and test our logic changes, so that was great. Manas and I have walked through the code to analyze the soil aridity, and we have set the pump to cycle between a specific range using screws as our soil aridity measures. There will be a video coming up in the next slide that will show you in detail what the progress looks like and show you the system in a functional state. As Amira has identified, we do have a couple of elements that we want to do as stretch goals, and Barbara will walk through those in the expected outcome. So here's a quick video of the system in progress.
Taking a quick look at the Team 14 plant watering system, our soil moisture monitor is set to anything that is less than 93% will set the pump running. We're about to turn the system into active mode. And once the system identifies that the percentage is less, we'll see the pump continue to cycle until the water percentage goes above. And there we go. And it'll run again. We're still at 92%, which means the pump will cycle again. And it'll keep cycling until such a time as it gets to 93%. Unfortunately, I don't know that our screws are really good soil testers, so I may have to adjust to 92% and recycle the system. And you'll notice that now that we've recycled the system to 92%, the soil moisture reading's at 93, the pump is no longer running and the system is in standby mode. Cut.
And then I will pass the mic on to Barbara to walk you through expected outcomes.
So to build on Craig's demo, the outcomes of this project was to create a planter titled the Garden Guardian that can solve the problem of busy plant owners forgetting to water their plants. This was to be achieved by creating a prototype that combined 4 key pieces, some of them that we're going to hear about again when we talk about challenges encountered during the build process. We do have some stretch goals for this project regarding the ability to notify users when the ambient temperature around the plant is too hot. This would achieve the use case of being able to warn users who might have the plant in the windowsill that it's time to move that plant. We also had an additional stretch goal of enabling a regular scheduling of the plant as well. For more detail about challenges that we may have encountered when trying to achieve these outcomes, I'm going to pass it to Monas.
Thanks, Barbara. Hi, everyone. This is Monas. So we developed the working prototype, but we encountered few problems during the whole process. For the prototype, we did not have the sensor, so we had to use nails, which did not give the accurate reading. Because of the lack of sensors, reliability was a problem. So here we are using a circuit library, Python circuit library to code on the hardware. We had to install everything, including library on the hardware, and we are not able to figure out how to install the Twilio library on the hardware. That's one challenge we are still facing and exploring and looking for alternate options. So initially, as you see in our write-up, that we intend to develop 4 individual prototypes, but we had to restrict to one as the cost of hardwares were increasing as we adding new hardwares and new things. And on the top of that, the expedited delivery cost was way too high. So another problem was shipping. So the shipment was taking too long to come, and we are still waiting on few hardwares. So with this, I will wrap this up. So this was our presentation.